All the best, Emu sir.
Thank you. So guys, today what I will cover your Palo Alto firewall high availability related all the questions with answers basically. So here I have chosen around 20 questions on your Palo Alto high availability. So these are the 20 questions. Like here I have put 10 and 10 I have put into my next slide. So these are the around 20 questions which I'm gonna discuss. So let's see how many we can able to cover today, and remaining we will basically, because see these webinars we are having on every Saturday. Okay, so you all will get the Zoom link for every Saturday, so you can join, and basically where we will cover all the things. So I am basically trying to cover all the question on Palo Alto firewall with regards to the topics. Like today I have picked HA, high availability, right? Maybe in next class I will cover like what is life of a session, then how your URL filtering works. So in URL, what are the questions asked in the interview? What are the question asked in app ID, right? So I'm basically trying to pick such kind of questions basically. Okay, so without wasting time, let me just start with the first question. What is HA and what type of HA is supported by the Palo Alto file? This is a very, very basic question, guys. So let me just answer this one. So HA stand for high availability. Okay. And your Palo Alto firewall supports two types of high availability solution. First one is active passive and second one is active. Now, what is the difference between active passive, or how your active high availability works? Let's discuss that thing, guys. So I will take the help of whiteboard. So if you will see, this is the topology which I'm having here, and I hope this topology is visible to you guys, right? So let's suppose this is my firewall 1 and this is my firewall 2. Now let's discuss active passive high availability. So in active passive high availability, what happens? Your one firewall, it will be take the role of active device, and another firewall will take the role of your passive device. Now all the traffic which is initiated by these LAN users, or let's suppose we have some users over the internet, right? And if they want to access these particular servers in your LAN environment, what they will do, all that traffic will be handled by the active device basically. This is known as, and this is your active passive high availability, means your active device or your firewall 1 will handle all the traffic actively, and your passive device, it is just sitting idle. When your active device failed due to any reason, what it will do, that time your passive device, it will take the role of active device, and it will basically start doing the data forwarding. So this is your active passive high availability. Now in Palo Alto firewall, another type of high availability is your active high availability. In active high availability, what happens? We have this firewall which is firewall 1. This firewall will become your active primary firewall, and your firewall 2 is become the active secondary device. Now in your active high availability, both devices, your firewall 1 and your firewall 2, they will do the data forwarding. Means some machines from your LAN side will forward the data towards your firewall 1, and some machine in your LAN side will forward the data towards firewall 2. Means both device doing the data forwarding at the same time. But just remember one thing with regards to your active passive or active design in your Palo Alto environment. See, first of all, around 95% customers basically, they always go with the active passive design. They never use this active design, guys. Just remember why they will not use the active design. There is a reason behind this. So maybe in your interview they will ask, why basically you will not recommend active design, or what is the use case where we can use active design, or where we will go with the active high availability deployment of your Palo Alto firewall. So let me just tell you one reason. There is a one small reason. Let's suppose this firewall, or let's suppose when we have both these firewalls, we are running on active passive, and let's suppose throughput of both the devices, let's suppose, is 10 Gbps, and the session capacity of both the devices, let's suppose, is 256,000. Now if you will deploy the same devices on active unit, you will get the same throughput, guys, and you will get the same session capacity, which means there is no increase on the session capacity and there is no increase on the throughput. This is the one of the biggest reason. Basically, Palo Alto is also recommend always go with the active passive design. Now if they will recommend active passive design, then why we have this active design, guys? So there is a one use case, and we have to understand that use case where we have to go with the active design. So let me just explain that particular use case. So let's suppose you have an environment where I have my firewall 1 here and I have my firewall 2 here. These firewall, they have a connectivity with these HA links. Okay, I'm not putting the name here for now. And after that, you have one router here, maybe router R1. Here we have another router, which is router R2. And this router have a connectivity with the internet service provider, maybe ISP1. This router will also have an internet connectivity with ISP2. And over the internet, because this is your internet cloud, all these ISP, they have a connectivity till here. And after that, here, let's suppose you have one server. This is one server here. Now, apart from that, you also have the environment here. You have router 4 and we have router 5 here. And after that, behind these routers, we are having our LAN environment and our DMZ environment. So let's suppose this is your LAN environment and your DMZ environment. Now, in this environment, let's suppose we have this user. Now, let's suppose this user, he wants to communicate with this server. So let's suppose he's forwarding his traffic. That traffic reaches to R4, then it is going towards firewall 1, then firewall 1 will forward towards R1, then ISP, then ISP will forward this traffic towards the server. Now, due to asymmetric routing in the environment, basically, what happens when this server, he's sending the reply from different path, because you have some asymmetric environment, guys. So if you have this kind of environment where your request packet will follow one path and your reply packet will follow different path, guys. In these kind of scenario, we have to go with the active design. So your firewall 1 is also active device and firewall 2 is also active device. So this is your active primary and this is your active secondary. And now they can both do the data forwarding and they can both do the load sharing with each other. So this is the only design. So if you have a asymmetric routing environment, in that case only you can go with the active design. Otherwise, active design is not recommended by the Palo Alto as well, guys. Okay, so this is the answer of what is high availability, what type of H is supported by your Palo Alto firewall. Now let me just go here. What is active passive and active? This thing also I have explained. Now let me go here. Let's suppose we have this particular environment, which means how upstream and downstream switches knows when firewall switch over from passive to active unit. Let's suppose we have this particular environment here. So let me go back into my topology. In this topology, let's suppose this device is running as an active device and this device is running as a passive device. Now, due to any reason, this active unit failed. Let's suppose this active unit failed, which means that time your passive unit become active. Now guys, this particular switch, this is a upstream switch and this is your downstream switch. How they will know? They have to basically start sending the data towards this device. What is the mechanism used by these particular firewalls to achieve this thing? So guys, just remember one thing. The answer for this question is simple. Whenever failover happens between your firewall 1 and firewall 2, what they will do, the device who will take the role of active, he will basically sends the gratuitous ARP basically, or we can say it will sends the GRP towards your downstream switch, and here also it will send the GRP. When he will send the GRP, your upstream and your downstream switch, they will update his MAC address table and ARP table, and after that they will send all the data which is initiated by these machines towards your firewall 2. That's how they will basically get to know. They will send the GR. Now let's see this particular behavior, guys. So right now I'm running. So I'm running my firewalls in active unit right now, guys. So I'm running these on active unit. So what I will do, let me just start the capture on one of the interface here, which is gig0y1. Let me start the capture here. I've started the Wireshark capture. Now, what I will do, let's suppose I will make this device down. And you will see in the Wireshark captures. Just wait here. You will see this particular R packet they will send. This is the gratuitous R packet they will basically send towards your switch. So your switch gets to know there is a failover triggered between your firewalls basically. So that's how they will get to know there is some activity happens with regards to your high availability. Okay, so the answer for this question is very simple. They will send the gratuitous ARP towards the upstream and downstream switches, and when your upstream and downstream switches receive the gratuitous ARPs, they will update the MAC address table basically, and after that they will start sending the traffic towards the other firewall who just become the active unit. Okay, now in high availability they will ask one more question. It's a very popular question, guys. What is HA1 interface? What is HA2 interface? Or what is HA3 interface in your Palo Alto high availability? This question maybe they will ask in this way. What is HA1, HA2 and HA3 interface? Maybe they will ask in this way. What is control interface? Or what is control link? What is data link in your Palo Alto firewall basically? So if you want to answer this question, so just remember one thing. Let me just go here. I have basically have this particular diagram, guys. So in this diagram, if you will see, this is the Palo Alto firewall basically. This is your firewall 1, let's suppose. This is your firewall 2, let's suppose. So let me just write down here firewall 2. Now, in your firewall, everyone know they have a management plane and they have a data plane, right? They have a management plane and they have a data plane. So guys, your HA1 interface is your control link, just remember, and your HA2 interface is your data link. Now your HA1 interface is a part of your management plane and your HA2 interface is a part of data plane. What is the use of this HA1 interface? So we will use this HA1 interface for configuration synchronization, because all type of configuration we will do on your firewall 1, that configuration is automatically synchronized with firewall 2. So it will do the configuration sync. This interface we will also use for sending the heartbeat messages and your hello messages. These heartbeat messages basically exchange between your firewall 1 and firewall 2 through HA1 interface, guys. And now just remember one thing, why we exchange these heartbeat messages. These heartbeat messages are the ICMP ping messages, guys. These are the ICMP ping messages, and we will exchange these messages between firewall 1 and firewall 2 to tell the state of each other, or we can say to check other devices live or not. These messages also used for checking the health of the other device, means other devices up or running, or it is basically down, how they will basically check. So they will check because they will send the heartbeat messages. If they will miss the heartbeat messages, they will get to know other devices failed basically. So that's why they will exchange the heartbeat message. Now these, why they will exchange hello messages, guys. So just remember one thing. So I will cover this question, why they will exchange hello messages, because I want to also tell you one more thing here. So guys, if you know what are the prerequisite basically to configure your firewall 1 and firewall 2 in HA pair, what are the prerequisite? They should have a same mode. So there is some hardware requirement, right? There is some software requirement, there is some license requirement, right? When these requirement will fulfill by both the devices, then only we can able to configure on HA. So let's say what are the hardware requirement. Both firewall will have the same model number, which means if your firewall 1 is 30 to 20, then your firewall 2 should be also 30 to 20. If your firewall 1 is 30 to 20 and your firewall 2 is 30 to 60, in that case we will not able to configure them on a HA pair, means your hardware model should be same. If we have a same hardware model, which means they have a same number and same type of interfaces as well, which means if your firewall 1, he is having 4 fiber ports and 8 copper ports, which means we need a same type of environment or same type of interfaces on firewall 2. It should also have the 4 fiber ports and 8 copper ports, guys, just remember. And after that we have a software requirement. Software requirement means both firewall have a same pan OS version, guys. What? They have a same pan OS version. They have a same dynamic updates. They have a same dynamic updates for your application updates, your application signature updates, your wildfire updates, your thread updates, all these updates, right? They have a same URL filtering license. If firewall 1 is using PanDB, then firewall 2 also be in PanDB only. If your firewall 1, let's say using PanDB URL filtering license, and your firewall 2 is using your, so like there is a two solution. One is PanDB. This is the one of the Palo Alto solution. There is another solution is, this is a third party solution which is owned by the Webroot company basically. Okay. So if they have a same license for firewall 1, which means if it is having URL 4 license, which is your PanDB license, then this firewall also have the same URL 4 license. Okay. So this Webroot solution is also known as Bright Cloud URL filtering solution, guys. Okay. So these requirements should be similar. Both have the same type of license requirement as well, guys. So these are the some prerequisites. Now, how basically your firewall 1 or firewall 2, they will get to know they are running the same model number. They have a same hardware. They have a same PAN OS version. How they will get to know? They will get to know because through this control link or through HA1 link, they will exchange these hello messages, guys. They will exchange these hello messages. That's how they will get to know they are having the same hardware software licenses on both the firewalls or not. How they will get to know? Your firewall one, it will send the hello message with some kind of MD5 hash values. If there is a mismatch with regards to version, dynamic updates, license, that MD5 hash value will mismatched. So that's how they will get to know these things. They will exchange through these hello messages, guys, through your HA1 interface. Now, let me just go here. Your HA2 interface is known as data link, basically. This interface is used for session synchronization, your forwarding table synchronization, your IPsec security association synchronization, your ARP table synchronization. And just remember, your HA2 interface we can configure as a layer 2 or as a layer 3. But your HA1 is always a layer 3 interface, guys. And your HA1 interface on firewall 1, it will communicate with firewall 2 using the TCP port number 28 when we enable the encryption between with that communication which is happening through HA1 interface. Otherwise, by default, it will use port number 28769. Your HA2 interface, basically, we can configure layer 2, layer 3. If we will configure on a layer 3, that time what it will do? It will use the ether type, which is 0x7261. This is the layer 2 ether type it will use. If we will configure as a layer 3, that time it will use either IP protocol 99, either it will use UDP port number 29281, basically. So you have to remember these details, guys. This is your HA1 and HA2 interface. Now we have a HA3 interface as well, guys. So your HA3 interface is come in a picture. So let's suppose this is my HA3 interface and I'm running both the firewalls in active unit. So when you will configure, when you will run your firewall in active, that time your HA3 link come in a picture. And that HA3 link we used for if your firewall 1 wants to communicate with firewall 2, or they will send some data traffic, because in HA, active HA, there is a concept of session owner and there is a concept of session setup. So if your session owner and session setup wants to communicate with each other, that time they will basically exchange the user's packet through HA3 interface, guys. Just remember. So that's the use of your HA3 interface and your active design. Now, let me just go in little bit depth here, guys. So through controlling, what they will exchange hello messages, your heartbeat messages, your configuration synchronization, and apart from this, they will also exchange some other management plane capabilities, which is your IPT user mapping, user to group mapping, and that thing is done by the user ID daemon, guys. Your DNS cache information, your DSCP information, and that thing is done by the DSCPD daemon. And your FIP tables, which is done by the route D daemon. So this is the information which they will exchange your through HA1 interface, because I have seen in interviews they will ask what are the information is exchanged between firewall 1 and firewall 2 through HA1 interface, guys, and you have to answer like that. This is the information: hello messages, heartbeat messages, configuration sync, IPT user mapping, DNS cache, DSCP, release time, and all these details, and FIP tables. I'm not going with the HA1 backup here. Now, why we use this HA2 interface? Through this HA2 interface, we will exchange the session table or flow table or a connection table means we will do the session synchronization, your MAC address table, your virtual MAC address table, your DOS block table, your virtual MAC address, guys, this is not a table. This is the MAC address table, your IPsec ACID detail, SCTP association, and your ND table when we will run your firewall in virtual wire deployment. Okay. So this is the information which is exchanged through HA2 interface, guys. So this is all about your HA1, HA2, and HA3 interface in your Palo Alto firewall. Now, how passive firewall know there is a config change in your active device? How? Because this is also most popular question, guys. I'm just keeping this question very small, guys, and I will go here now. If you know, everyone know who is basically working little bit on your Palo Alto firewall, you will know we will do all kind of configuration in your active device, right? And all the configuration is synchronized with the active device, with passive device. How they will basically get to know there is a config change. So guys, as I have mentioned, through HA1 interface, they will exchange this hello messages, right? Now this hello messages, what it is having some kind of MD5 hash value of your configuration file. So because you know this device, it is having one local configuration file or local candidate configuration file. And this device also have a local candidate configuration file. So what it will do when he will send the hello messages, what it will take the this local candidate config file, it will run the MD5 hashing algorithm on this file, and he will get one number. Let's over here get this number A, B, C, D, E, F. This is the number he will get, right? He will send that value towards the this hello message received by the passive firewall through HA1 interface. Now what passive firewall will do, he will also have the local configuration file. He will also run the hash MD5 hash. He will, let's suppose he get the value which is A, B, and after that he is getting something else. If there is a config change, which means whatever configuration file we are having here, if and whatever configuration file we are having here, if there is a change with regards to the configuration, what they will do, this hash value will change. If this hash value will change, your passive device gets to know there is some config change happens, and after that he will request firewall 1 to synchronize the configuration. That's how they will do the config sync, guys. And just remember one thing, your config sync is always done by the HA1 link only. If you have a HA1 backup interface, guys, that interface will not used for configuration sync. That interface is only used for exchanging the heartbeat messages and hello messages. Your config sync is always go through the HA1 interface. Just remember. This is also an interview question. They will ask you, they will confuse you. Can firewall 1 and firewall 2 do the config sync through HA1 backup interface? You have to tell straightforward, no. Config sync is only happens through your HA1 interface. Now, if I'll go here, let me just show you something here. So right now I'm on my firewall 2, and let me just take the access of my firewall 1 as well. This is the wrong device I'm opening. So let me just open this one. It will open automatically. Generally, what we used to do, we always used to run, there is a one command which is known as less mplog haagent.log. This is the log file we will check, guys, always. And in this log file, you will see they will exchange these capabilities messages, and below this capabilities message, you will have this hello message, right? So you will get these kind of values there. This is the hash information, guys. This kind of hash information they will exchange. Okay. This information. HA to backup MAC address details, all things you will see here. Okay. If there's any change, you will get the mismatch with regards to this hash values. So I'm just showing the old log, guys. These are not the latest log. Okay. Because I have just configured these devices in the morning. So this is the daemon file which we have to check. So if you want to check the live logs, always run the command like this: tail follow yes mplog hagent.log. If you run the command in this way, you will get the live logs, what's going on right now. If I'll do one thing here, let's suppose, let me log in on my firewall one. Let me just do some config change. Let's see this particular thing, how this thing happens. So let me just log in and I will just add some configuration here and we will check the HA agent daemon logs here. So I also got the access of my firewall one. Let me also run the debug here. Tail follow yes mplog HA agent.log. This is the daemon, guys, who will take care of the H related functionality. You will see I am running active right now. Local is active secondary, another one is active primary. This is the firewall who is active primary right now. So let's see. So what I will do, let me go into objects. Let me add few objects here. Let me just add here one test object, 1.1.1.1. Let me just do the commit now. I will do the commit. Now you will see here, commit is going on. We will monitor the things here. Now you will start seeing some logs here, guys. See, they are exchanging these hello messages, right? Even though if you want to see details in a broader way, what I can do, I can also do one more thing here. Let me just capture the packet on my HA1 interface, which is Ethernet 1x3. So capture is going on, guys. Wait here. We will got the debugs here after some time because right now commit is going on our first device. Once this commit will complete, we will see the details. So we will wait for some time, guys. Let's see this thing practically. Right now, see, config is in synced right now. Just wait here. It is 0%. It is doing some validation, guys. If you don't know the commit, let me just give you some little bit information of commit, guys. So in Palo Alto firewall, when we run the commit command, what will happen? Commit process will go through three phases: phase 0, phase 1, and phase 2. In phase 0, it will check where it has to store the configuration and all, right, for all the objects. In phase 1, it will do the validation. In phase 2, it will basically actually implement the things. You will see here 98% right now. So we will wait for some time. You will get to know here after some time there is some little bit unsynchronization, right? That's why I'm just running the refresh here. It's in 99%. So let's wait. See, session synchronization is in progress. How this happens automatically? If you go here into these log files, see the log file. Control C. You will see config MD5 checksum. This is the MD5 hash value they will exchange basically. This is the previous one. This is the new one. That's how they will get to know there is a change. There is a config change basically. Now they will start the synchronization. So they will send this kind of hash values, guys. Okay. What? You will get the details here. Got the new config MD5 hash, this value. New MD5 hash is this value. These values are changed, right? If these values are changed, which means set new MD5 configuration comparison. Okay. We were in sync and now we are out of sync. Now auto commit will happen. What is this auto commit, guys? This is the cron jobs run by the Palo Alto firewall. Because when this cron job runs at the multiple places, guys, okay, auto commit will run and your session synchronization will happen between firewall 1 and firewall 2. So this particular hash value they will send and they will compare. Okay. So this will answer your how passive firewall know there is a config change in your active device, guys. Now what we will do, how session synchronization and config synchronization happens. So we have already seen how the config sync happens. They will check the MD5 hash value and all. Now let's see how session synchronization is done by the Palo Alto devices. Even though if you want to see, these are the captures I have taken, guys, and I have told you, right, they will communicate on port number. There is a one port number, so they will use ICMP. And because we have captured lots of traffic here, they will use port number 28769 for the communication purpose. Just remember, they are also using 28260. This is for some different purpose, guys, because your system daemon will also communicate between firewall 1 and firewall 2. If you want to see what is the what are the basically what is the configuration they have synced with each other, let's see that detail as well. So let's follow the TCP stream. You will get to know. Let me just change this value. This is the configuration they have synced with each other, guys. This is the config synchronization they have done just now. We can capture everything, guys. Somewhere here you will get that particular test object, which is this one. Okay. This traffic is by 1.1.1, which is firewall, and towards 1.1.1.2, which is firewall 2. Let me just quit from here. Now, what is this session synchronization, guys? Because if you will see here, so right now, if I'll go into my firewall one, let me press here controls. If I run this command show session all, I don't have any session. On this device also, show session all. I don't have any session. If I'll run here one more command, show ARP. So ARP all. I have this particular ARP table, right? I will run this command here as well. So ARP all. I have this ARP table. I'm having same ARP table. Now let's do one thing. Let's go to into my topology here. Let me just open my router. Let me initiate some traffic from this router towards this switch. So what I will do, I'll go here. I'll just do the telnet on my outside switch, which is having IP 192.161.99. This IP address is there on this switch. Let's see. So if it is not working, that is okay. Looks like I have breaked something. If I run this command show session all now, no active session right now. I'll go here into this device again. Let me just open this device, this switch as well. This is my inside switch. So IP route, let me just check. Okay, I don't have any route. So IP interface brief, all my interface in up state and my VLAN is in down state. VLAN 10, exit. Interface range gig 0x0/4 till 3. Switch port mode access. I have to configure this command. Switch port access VLAN 10. No shutdown. Exit. Now see, interface came up because that was the issue. Same issue I was thinking on this device as well. Looks like this. This is not active right now. So IP interface brief. Yep, it is also down state. Interface range gig 0x0 till 4 or 3. Switch port mode access. Switch port access VLAN 99. Exit. Do so IP route. Now you will see I have the route, right? So things are good now. Do right, ma'am. Let me just initiate the traffic now. Let's see. See, I got the access. Cisco is the username and password is also Cisco. Now, if I'll go here, you will see this session on both the devices. I have the telnet session here, initiated by 10.1.1.100. It is going towards 192.161.1, right? This is the source port 63818. Go here, run the command here. So session all. Same initiated by this machine. Port is same, which means this is the same session, right? So what happens, guys? Your firewall, when they are running on active or active passive, they will do the config sync basically, or they will do the session synchronization, and they will do the session synchronization through your HA2 interface, guys. Just remember, they will do the session synchronization through your HA2 interface. That's why you can say Palo Alto supports the stateful failover. Which means if this device went down due to any reason, you don't need to reinitiate that connection. That connection will relay through your firewall too as well. Okay, that's how they will do the session synchronization, guys. Apart from this, if you go here, if you run this command, so ARP all now, you will see some ARP, extra ARP as well, right? And you will get the same details here as well. So they will do the ARP synchronization also, guys. Just remember. Okay. Now, let me just discuss what is heartbeat backup, guys. What is the use of heartbeat backup? So if you want to understand this heartbeat backup, let me cover what is a split brain in your Palo Alto firewall, basically. You will come across this particular thing, a split brain situation in your Palo Alto firewall. And let me just discuss that part, because they will ask you what is a split brain. And if you don't know the answer, which means they will consider you don't know the basic functionality of your firewall or basic functionality of high availability. So in a spread brain, what happens? Let me just tell you one thing. Let's suppose we have here firewall 1. We have here firewall 2. Now, if you want to configure HA between this firewall, you have to configure HA1 interface, right? And you also need to configure HA2 interface, right? This is your control link. And this is your data link. Now, let's suppose here we have one of the switch. Here also I have one of the switch. I have my users here. This is my LAN environment. And this switch have a further connectivity with the internet service provider, ISPs. This is the right now setup I'm having. Now let's let's go into the basics. Basically, if you remember, I have mentioned through HA1 interface, they will exchange the keep alive messages. Keep alive messages, also known as your heartbeat messages, guys. What? They will exchange these heartbeat messages through HA1 interface. Now, why they will exchange these heartbeat messages? These heartbeat messages exchanged by firewall 1 towards firewall 2, and firewall 2 will forward towards firewall 1. They will exchange these heartbeat messages to tell each other, I am alive. Firewall 1 send to firewall 2, I am alive, and firewall 1 tell I am alive and I am in active state. This message firewall 1 will send. And firewall 2 will send, I am also alive and I am in passive state. And according to our configuration, let's say this is your active unit, this is your passive device. Now, let's take an example. I have here one PC. On this PC, default gateway is this particular IP address. This is Ethernet 1x1 interface, let's suppose this is Ethernet 1x2. And in your active passive unit, guys, we just have the IP address on active device. So let's suppose this interface have IP address 10.1.1.250. So let's 20. This IP address is fixed, guys, here. Okay. Now, so all the traffic from this machine is forwarded towards the firewall one, right? Towards the active unit. Now, let's see the example here. Let's suppose on our switch, we have F0x0, we have F0x1 and F0x3 or 2. Now on this switch, what he know? He know 10.1.1.250 is reachable via F0x0 interface, right? So because first traffic we will send to switch, and after this switch will forward towards the firewall. Now let's suppose, let's take an example here. Let's suppose due to any reason, this interface goes down. If this interface goes down, what will happen? Which means now your firewall 1 and firewall 2 will not able to exchange the heartbeat messages, right? If they will not able to exchange the heartbeat messages, which means your firewall 1 will not able to inform to firewall 2, I am active device, and firewall 2 also not able to inform to firewall 1, I am a passive device. That time what they will think, your firewall 1 thing, your firewall 2 is failed, is down right now. So what he will become active device, and your firewall 2 think firewall 1 is down. So what he will do, he will also become active unit. If both these devices, they will become the active, and right now this IP address 10.1.1.250 is active on this interface, and the same IP address is also active on this interface. Now this switch, he will get confused 10.1.1.250. Sometime he will get it is reachable by F0x0, sometime he will get it is reachable by F0x1, because both will send the GR, right? Both update the gratuitous ARP. He will also update the GR, right? Now, so what happens? This is the case where both unit is consider themselves as a active unit, guys. This is your split brain situation. A split brain situation, which means your both the firewalls will do the data forwarding, which means what will happen? Your first packet go here, second packet go here, first packet go here, then another one here, then here. So what will happen? Which means your packet is all the packet is dropped. There is no proper synchronization, guys. So that is known as a split brain situation, guys. How we can solve the problem of this split brain? There is a one solution for that. What you can do, you can introduce one more interface between firewall 1 and firewall 2, and you can think this is your HA1 backup interface. means configure the HA1 backup interface. So if your HA1 is in down state, your HA1 backup interface they will use for exchanging the heartbeat messages and hello messages. Now, one more thing. Let's suppose this HA1 backup is also went down. Your HA1 is down, HA1 backup is also down. Now, there's a one more solution. What you can do? You can connect the management connectivity. You can enable the heartbeat backup through your management interface as well. So through your management interface, they will only send the heartbeat messages, guys, nothing else. So that is your heartbeat backup thing, guys. That's how your heartbeat backup come in a picture, and it will basically solves the problem of your split brain situation in the network. Now, if you want to see how they will communicate with each other, right now I have enabled the heartbeat backup. So if I run this command, show netstat numeric, yes, match what I want to match 192.168.137.10. So you will see there is a one heartbeat backup connection is there, and there is a one raw connection is also created between firewall 1 and firewall 2. These are the management interface IPs, guys. This raw connection they will use for exchanging the ICMP messages or your heartbeat messages. Same thing is also there if you will run this command 1.1.1.1. You will see there is a one raw connection is established between firewall 1 and firewall 2 through HA1 interface, right? This connection they will use for exchanging the heartbeat message. If you will go with 2.1, you will get one more raw connection here as well. So that's how they will communicate with each other, guys. Okay, now, so this is your split brain and this is your heartbeat backup. So we can use HA1 interface as a heartbeat backup, and also we can use management interface as a heartbeat backup. How you can enable? We can enable that feature if you will go into your device tab, into your high availability, general settings. Go here. Let me also go into this device because it's become slow. You will see this heartbeat backup, right? Right now it is grayed out because it's loading the settings. So here we have to enable the heartbeat backup option for management interface, guys. Okay. Now it's taking lots of time. So let's see. Now, meanwhile, let me just explain you what is preemption, guys, because they will ask what is the role of preemption in high availability environment, guys. So let me just take the help of one of the image here for preemption. So guys, in your Palo Alto firewall, what happens? This preemption feature, what it will do? It will always make sure the device, let's suppose you have a firewall 1 and you have configured this firewall as an active device, which means you have a priority value is 50 on this device, let's suppose, and you have configured firewall 2 as a passive device where you have configured priority value which is 100. Let's take an example. If you have configured the priority values like that 50 and 100, which means your firewall will become the active and firewall 2 become the passive. So just remember, always just remember, if you will enable the preemption, so this preemption always makes sure if your firewall 1 is active, or your firewall one is online or it is up and running, it will make sure it will always take the role of active device. Active device means it will become, or it will become the active unit always. It will just make sure your firewall one become the active unit once it will online or if it is up and running, guys. So let me just tell you one situation here. Let's suppose I have firewall one and I have firewall two. We are running these firewalls on active passive mode. This is your active unit. This is your passive unit. Now, let's suppose there is a one time. So I'm just writing here time. Let's suppose at 12 p.m. What will happen? Due to any reason, this device is failed or this device is went down due to any reason. So what will happen? Your firewall to it will become the active unit, right? And after that, what when we see the SNMP alert, what we will do? We will do some troubleshooting. And at 12:30, let's suppose 12:30 p.m., this device came online. So when this device came online, what it will do? It will become the passive unit initially. And this device keeps acting as an active device. And what will do? Now this device keeps acting as a passive and this device keeps acting as an active device. If you will enable the preemption, guys, means this is the case where preemption is not enabled. If preemption is enabled, so what will happen? At 12:30, your firewall one, it will become the passive device and it will wait till 60 seconds. This is the preemption hold time. Preemption hold time. It will wait till 60 minutes and will become the active unit again. And this device become the passive unit. So your preemption, what it will do, it will always make sure your active unit will be in active unit, always be in active mode if it is up and running, guys. This is your preemption. Now in active design, what are the use case, or basically what are the deployment method we are having for active unit, guys? So your active deployment method is, let me just write down few methods here. So the first active deployment is known as floating IP deployment. Floating IP deployment. This is the one of the method. It's ing here. Floating IP deployment. The second deployment method is your rpload share deployment. Rpload share deployment. Your third active deployment method is your mixed mode deployment. In mixed mode deployment, what will happen? We can use on our WAN side. On our WAN side, we can go with the floating IP deployment. At your LAN side, we can go with the rpload share method. And the fourth deployment is when we have a asymmetric routing environment. So these are the four use case of your active deployment method. Generally, guys, you will see your active deployment in this scenario is only where we have a asymmetry in our environment. Okay. So these are the four use case of your active design, guys. Now, what is the heartbeat message and hello message? So I think I have already discussed these messages in detail, right? Your heartbeat messages is used for conveying the state of each other. And we will exchange these heartbeat messages to check the liveliness of your peer. Means your peer is live or not. We will use this method to check the health of your other peer. These are the kernel level pings, guys. And these pings we will exchange through HA1 interface. your HA1 backup interface, and your management interface as well if we have enabled the heartbeat backup through management interface. Hello messages is also exchanged between firewall 1 and firewall 2, guys. And these hello messages we will exchange, where they will basically tells about the config sync details, right? All these kind of information is included into your hello messages, your dynamic updates versions, right? Your PanOS versions, all these details they will exchange through the heartbeat message, hello messages, guys. Okay, so these are the 10 question, guys, which I want to cover with regards to today's session. In your next session, I will cover what are the ports we need to allow in a firewall if it is in middle. What are the prerequisite for firewalls if we want to configure them on a HA pair? What is session owner and session setup in active unit? What are the daemons involved in Palo Alto firewall HA? What are the HA states we are having? What is the link monitoring and path monitoring? What is Palo Alto? So we will discuss Palo Alto advanced architecture diagram also for HA, guys. What is HA agent? What is pen DHA daemon, right? We will discuss regarding that as well. How we can upgrade the devices if we are running on HA. What is the role of system daemon in your high availability? So these are the some tech related interview questions, guys. Okay, and we will also share you one Google form, guys, where what are the questions you have faced in your interview with regards to Palo Alto, you can also write these questions. So we will also start picking these questions and we will start explaining them, guys. Now, this particular session recording you will get into our portal, which is already mentioned by Bidish sir. So let me just open that portal for a minute, guys. So here you will get these particular recordings, and I am going to upload this particular recording inside. You will have a one course with the name of Palo Alto 5 interview question and answers. Here you will get all the questions. Here I have already uploaded my last class where I have explained how you can troubleshoot the Palo Alto firewall issues using global counters, your packet fill, packet captures, packet filters, and flow basics. So here you will get how your tech pupils or any professional troubleshooting you can do on your Palo Alto firewall. So you can refer that video, guys. Thank you, guys.